Somewhere in the last 10 years, something incredible began to happen. Our machines started to learn. Not just calculate, not just compute, but learn like we do. Today, a machine can see, it can read, it can write poetry, diagnose disease, drive a car, even create art. This isn't science fiction, it's not tomorrow, it's today. But how? What makes it all work? What is AI really built from? The answer lies in a set of simple yet profound building blocks. Today, I'm going to show you those blocks, not as an AI scientist, not as a programmer, but as a human being, because artificial intelligence is not just about machines, it's about us. This is the story of how we taught machines to think, and maybe in the process, learned a little more about ourselves. Building blocks of artificial intelligence. What is intelligence? Before we can talk about artificial intelligence, we need to talk about intelligence itself. What is it really? Is it the ability to learn, to solve problems, to imagine the impossible? Is it memory, pattern recognition, creativity, emotion? Intelligence at its core is the ability to take in information and turn it into action. It's adaptation, it's survival, it's evolution, compressed into thought. And for thousands of years, it belonged only to us. Now, for the first time, we're sharing it, not by accident, but by design. We are building minds, artificial minds. But to build one, we must understand what makes one. So let's go back to the beginning. Let's break it down one block at a time. Because when you understand what intelligence is made of, you understand what's coming next. The building blocks of artificial intelligence are data, the fuel of AI, machine learning, teaching machines to learn, recommender systems, the algorithms that know you, neural networks and deep learning, mimicking the brain, computer vision, teaching machines to see, natural language processing, NLP, understanding human language, time series forecasting, predicting the future, GANs, the art of imagination, LLMs, machines that read and write, reinforcement learning, learning through action, generative AI, the new creative class, LLMs, thinking, acting autonomously. Let us explore each step by step. Data, the fuel of AI. Everything begins with data. Without it, artificial intelligence is like a mind. Without memory, right now as you watch this, the world is generating data. Massive amounts of it. In 2025, we're generating over 463 exabytes of data every single day. That's 463 billion gigabytes daily, more than the entire internet produced in its first 30 years, created in just 24 hours. By 2030, that number will double. Data is what we see, what we hear, what we say, what we type, every email, every photo, every search, every GPS ping. It's all data. But raw data is just noise. It needs context. It needs meaning. It needs learning. Data becomes powerful when it's transformed into insight. That's what machine learning does. It takes data and turns it into decisions. What AI knows is only as good as what it's fed. If you give it the right examples, it learns. If you don't, it guesses. And just like us, what it learns shapes what it becomes. So we've gathered the fuel. Now, let's build the engine. Machine learning, teaching machines to learn. If data is the fuel, then machine learning is the engine. It's how we taught machines to do something we never imagined they could: learn. Machine learning is simple at its core. We show a system enough examples, and it learns to make decisions on its own. Show it thousands of pictures of cats, it learns to recognize a cat. Not because we programmed it to, but because it found the patterns itself. This is called supervised learning. The machine is given the question and shown the answer. Sometimes it isn't told the answer. It finds patterns on its own. We call this unsupervised learning, discovery without instruction. And sometimes it learns by trying, failing, and trying again. That's reinforcement learning, and we'll get to that soon. You've seen machine learning at work every day. Every time Netflix recommends your next show, or your email filters out spam, or your bank flags a strange transaction. We're not telling machines what to do. We're showing them enough of the world that they figure it out for themselves. This is the moment when a machine becomes more than a tool. It becomes a student, a learner, a kind of mind. And some of the most powerful applications of machine learning aren't flashy. They're personalized. Let's explore the algorithms that know you better than you know yourself. Recommender systems, the algorithms that know you. You didn't ask for that movie, or that song, or that ad, but somehow it found you. Recommender systems are everywhere. They decide what you see, what you buy, what you click, what you binge. At their core, they do one thing. They predict what you'll love next. Some systems look at people like you. Others look at the things you already like. Over time, they learn your taste, not because they know you, but because they know your patterns. Your choices become your fingerprint. In a world drowning in options, the most powerful AI isn't the loudest. It's the quiet one, whispering just the right thing at just the right time. Recommender systems shape what we consume, and in doing so, they shape how we think. But to unlock the real power of learning, we had to look inward, at the most complex system nature ever built, the human brain. Neural networks and deep learning, mimicking the brain. We looked at the most intelligent system on Earth, the human brain, and we asked a simple question. What if we could build one? A neural network is not a brain, but it's inspired by one. It's made of nodes, neurons, and layers like pathways of thought. Each neuron takes an input, processes it, and passes it forward. Together, they form something more than code. They form intelligence. We feed it data, it makes a prediction, we compare that to the truth. Then, like a student learning from a mistake, it adjusts itself. This process is called backpropagation. The more layers it has, the deeper it becomes. And that's what deep learning is. Deep learning powers the impossible. It's how AI recognizes your face, hears your voice, paints pictures, writes code. It doesn't just memorize, it generalizes. And that is learning. And once machines could learn, we taught them to see. Computer vision, teaching machines to see. Seeing is one of the most powerful things we do. It's how we understand the world in an instant. A smile, a face, a red light, a sunrise. For years, AI could calculate, it could learn, but it was blind. Then, we taught it to see. Computer vision is how machines make sense of images. They don't see pixels, they see patterns. The machine breaks down what it sees, edges, colors, forms. Then it learns to recognize what those patterns mean. Face ID, autonomous driving, cancer detection, all powered by vision, artificial vision. This isn't a camera. This is a mind interpreting light. And with each image, each pixel, each frame, it sees more. It understands more. Now that it can see, what if it could listen? What if it could understand us? Natural language processing, NLP, understanding human language. Language is the bridge between minds. It's how we express ideas, share stories, pass down knowledge. For thousands of years, language belonged to us alone. Now, we're teaching machines to understand it too. Natural language processing, or NLP, is how machines read, interpret, and respond to human language. It starts by breaking down sentences into pieces, patterns, relationships. It maps words into space, not alphabetically, but meaningfully. You've seen NLP in action, when your phone finishes your sentence, when Siri answers a question, when you speak and it replies. But this isn't just about words, it's about meaning, intention, emotion. We're not just teaching machines to hear, we're teaching them to listen. Now that AI can understand what we say, what if it could understand what comes next? Time series forecasting, predicting the future. We live in patterns, the rhythm of footsteps, the rise and fall of markets, the beating of a heart. And in every pattern, there's a whisper of what comes next. Time series forecasting is how AI learns from the past to predict the future. It looks at data over time, temperature, sales, traffic, electricity. It finds trends, seasonality, anomalies, and then it forecasts what happens next. Hospitals use it to plan resources. Retailers use it to stock shelves. Economists use it to read the economy's pulse. Think of it like a memory stretching across time. The longer it remembers, the better it predicts. In a world that changes every second, forecasting isn't just useful, it's essential. So far, we've seen how AI can learn, understand, predict. But what happens when it begins to create? GANs, the art of imagination. We taught machines to learn. We taught them to see, to understand, to predict. But what if they could imagine? GANs, Generative Adversarial Networks, are a kind of artificial creativity. One network creates, the other critiques. One generates images, voices, text, anything. The other decides if it's real. It's a game, a creative tension, two AIs locked in competition. And from that tension comes something new. It's not copying, it's not guessing. It's imagining something that's never existed before. But like all powerful tools, it comes with responsibility. GANs can deceive, fabricate, create realities that feel real, but aren't. Still, in the right hands, they're more than machines. They're artists. And while GANs create images and sound, LLMs create meaning. LLMs, machines that read and write. For centuries, we've passed on knowledge through words. From scrolls to books, to the internet. Language is how we think, how we remember, how we dream. Now we've built machines that read it all. Every book, every article, every conversation online. And they're learning from it. Large language models, LLMs, are trained on massive amounts of text. Not to memorize, but to understand. They break language into tokens, map relationships, learn grammar, style, intent. And then given a prompt, they write. They answer questions, summarize reports, write essays, draft code. They don't just speak English, they speak human. For the first time, we've built systems that don't just respond. They converse. They don't just generate text, they generate thought. But what if a machine could go further? What if it could act, explore, experiment, and learn from its own mistakes? Reinforcement learning, learning through action. We've taught machines to see, to listen, to read, to write. But intelligence is more than knowledge. It's action. Reinforcement learning is how machines learn through experience. Not by being told the answer, but by trial and error. The system takes an action. It receives feedback, and it adjusts. Each reward makes it stronger, each mistake sharper. This is how AlphaGo learned to defeat the world's best player. It's how cars learn to drive, how robots learn to navigate the world. The machine becomes its own teacher. Its failures become fuel. This is how intelligence evolved in nature. Not from perfection, but from persistence. And now, machines are doing the same. They learn not just what is, but what works. Visuals shift toward creativity, art, code, imagination. So what happens when machines don't just learn to act? What happens when they learn to create? Generative AI, the new creative class. For most of history, creativity belonged to us, the painter, the poet, the architect, the filmmaker. To create was uniquely human. But now we've built machines that can imagine. Machines that create art, music, poetry, film, from nothing but a prompt. This is generative AI. It doesn't search, it invents. It doesn't repeat, it reimagines. It's not replacing creators, it's empowering them. Amplifying imagination, accelerating vision. But with great creativity comes great responsibility. When AI can create anything, we must ask what we should create. In the right hands, generative AI is not a tool. It's a collaborator. But what if creation was just the beginning? What if AI didn't just think or imagine? What if it could act? Large action models, LLMs, thinking, acting autonomously. We've built machines that can see, machines that can write, create, even converse. But now they can act. LLMs, large action models, are the next step. They don't just answer your question, they get things done. Imagine asking your AI to plan a trip. It finds the flights, books the hotel, schedules your calendar, emails your team, and learns to do it better next time. LLMs combine memory, reasoning, tools, APIs. They're not just language models, they're action models. They don't wait for instructions, they plan, they adapt, they execute. We're not just building minds anymore, we're building doers, planners, partners. And when you put it all together, you get something more than intelligence. You get a system that sees, speaks, thinks, acts. Integration. The symphony. Individually, they are powerful. A model that sees, one that predicts, one that speaks, another that acts. But real intelligence doesn't live in parts. It lives in the connection between them. This is where AI becomes more than a tool. It becomes a system, a thinking, sensing, adapting, creating system. It sees the road, predicts the traffic, chooses the best route, and explains it to you in perfect language. It reads your email, understands your priorities, schedules your week. When these systems work together, AI stops being artificial. It becomes something more human. Each block is a voice, but together, they are a symphony. And what we do with this power begins now. The future is ours to build, a visionary close. We've built the blocks. Vision, language, memory, imagination, action. We've created systems that learn, adapt, and grow. We've given machines pieces of ourselves. And in doing so, we've built something new. This is not about replacing people. It's about amplifying what makes us great. But with great power comes a great responsibility. The question is no longer what AI can do. It's what we will choose to do with it. We are the authors of this future. And the greatest intelligence we can build might still be our own. The age of AI has begun. Now it's time to build something beautiful. Like, share, subscribe for more AI insights. Thank you. Stay tuned.